Okay guys, let's continue. Let's see how we answer these questions on a second theorem. So we have question number 1, as we're able to see, question number 1. So question number 1, what we have is this particular question here, as we're able to see. Now we are asked to find the angle marked with the letter A. So what you do, you first analyze the diagram, analyze it. We see here that we have got actually two sectors. We have got a minor sector, which we're able to see here, and of course we have got the major sector. And you see here that the angle we are looking for is actually lying on the circumference in the major sector, as we're able to see, and the angle is this one. So this simply means that according to one of the theorems, we see that the angle at the circumference of the circle will be half of the angle at the center. Now, what are we talking about? Well, as we're able to see here, we see that the angle at the circumference here is in the major sector. Are we seeing? If the angle at the circumference is actually in the major sector, then the angle that will be twice the angle at the circumference will be the angle in the minor sector, now at the center. Take note. Now, how do you find the angle at the center here? It's very easy because the rest of the angle is known as a 210. So how do you get this angle here? So that once we find this particular angle, it will be just a matter of dividing this angle by 2 so that we find what angle A is. Now, how do you do it? We simply do this. We say angle A is equals to, observe, 360 degrees, which is the angle around a point. Take away the 210 degrees, observe. Once we find the answer, we're going to divide the answer by 2. Then that will be angle A. Ideally, what we're finding is first the angle at the center. Once we find the angle at the center, we'll have it so that we find the angle at the circumference. Let's see now. So angle A, we can say angle A equals to, what's the distinction here? What's the difference? If you subtract 210 from 360, that will be 150 degrees divided by 2. What is divided therefore is 75 degrees, and this is how you find the answer. Are we together? Question number 2. Question number 2. We have this diagram here. Remember what I always tell you? First of all, analyze the question. If you look at the diagram itself here, we see that we actually have got a diameter. The diameter is 80 according to the statement. We are taught to take the line AD is called and the diameter. Now, from one of the theorems, we learned that any angle that will be formed in the semi, circle, we see that it will actually go up to 90 degrees. And from the look of things, this is what we are actually able to see. Angles in a semicircle, for example, talking about this semicircle here, we are asked to find angle B. So it's very easy. Angles in a semicircle, they go up to what? Let me ask. 90 degrees. So ultimately, without even wasting much of your time, by inspection, you simply say angle B is what? Is 90. But is that the only way? We can also borrow the idea of angle at the center being twice that one at the circumference. And from the look of things, we see that, the angle at the center with the reference to the angle at the circumference, we are talking about this angle here. So this angle here is actually right on the straight line. And this angle here at that 180 degrees. So this angle here is twice the angle that will be formed at the circumference. So for you to get the B, you simply have the 180. And that will what? So you see that this combination of two theorems. So it's quite interesting. Whichever you pick, that will be the answer. So in a nutshell, we say angle B, this was part A, check note. Part B, we are saying for us to find angle B, we'll simply say I use The angle at the center, take note, angle at the center is twice the angle at the circumference. So simply say 180 degrees divided by 2. And of course, we're going to arrive at 90 degrees. Therefore, angle B equals to 90 degrees. As though that is not enough, let's move on to finding another angle marked with the letter C. Observe, we have another angle here marked with the letter what? C. So from the look of things, we see that we have got a triangle. Like I said, you need to analyze the diagram, whatever is given, actually analyze it. And we see that we have got a triangle. And we see that this particular triangle has got no angles. This B is now 90 and we have 55. Plus this is C. What would be the sum of these three angles? 180. That would be what? 180. So for you to know this angle C, you simply say, observe. Let's move on to the same B. So we're going to say now for us to find the angle C, we say angle C is equals to 180 minus the two angles there. We have got 90, again we're going to subtract the 55. Observe. So angle C will equal to 180 take away 90. Let's see, 90. 90 take away 55. What is 90 take away 55? Sorry? 35. 35. Therefore, angle C equals to 35. Why? Because angles in any triangle, they add up to what? 180. But we know at least the two angles there. So it's easy to get this one. Simply say 55 plus 90 plus this one, give you 180. Then you make C the subject of the formula. Great. So that's another simplest one. See, remember what I always tell you, always concentrate on the diagrams. So what we're able to see here is this particular figure here which we have. From the look of things, we see that we do not have a cyclic quadrilateral. What we instead have is just a general quadrilateral, as we're able to see here. This is not a cyclic quadrilateral because one of its four vertices is not relying on the circumference. I remember, don't forget. Okay, this would have been a cyclic quadrilateral had this point been lying on the circumference. Then it would have been, a cyclic quadrilateral. So this point therefore invalidates this, quadrilateral from being a cyclic quadrilateral. So that's one of the aspects we do. Now, for the other things, we see that we have got again two sectors. We have got the minor sector, which we're able to see. This minor sector here and the major sector. Now we're asked to find angle X and angle Y. What are we going to do? It's very easy. We see that, look, we have the angle at the, center for the minor sector. Now, for us to know this angle X, it's important that we know the other angle in the major sector. So that once we know this angle in the major sector, for us to know the angle in the minor sector, the circumference, you will have simply needed to do what? To divide this angle by 2 so that we get to know what X actually is. And so it's very easy. So what we're doing here for us to find X, we say angle X equals to, we know we're going to first find the angle at the center, after which we divide by 2 so that we find angle X. So angle X is equal to 360 degrees minus the 130 degrees, okay? And of course, once we do that, we divide everything by 2. Now, what is the difference between 360 and 130? What is the difference there? 230. That is 230. That would be 230. 230 degrees divided by 2. That will be 115 degrees. Therefore, angle X is actually 115 degrees. And this is quite interesting. Look at it. Now, when we find angle Y, what do you think we're going to do?
150.
Exactly, because angle x and y are lying on the straight line. And we know to say angles on a straight line they add up 180. But we know this angle x as 150. So for you to know y, you simply say, okay, angle y, observe, angle y will equal to 180 minus the angle x, which happens to be 150 degrees. You see? And of course, we arrive at it. What is the difference there, please? That is 65 degrees. And this is the solution. Number two, also, you analyze the diagram. What we're able to see, we see that we've got two sectors. Once again, we have got this sector here, observe this sector here, and the other sector here. Okay, now we are asked to find angle mat E and angle mat D. So what we're able to see here is that apart from the sectors, we're able to see the isosceles, triangle. This triangle here is the isosceles, meaning this side here and this side are actually equal because these are the two radii. Check note. So it will be very easy to find it, A and D. Now look, we're able also to see that for the angle at the circumference in the major sector, which happens to be half of the angle that will be formed in the what? In the minor sector. So for you to find the angle E, you simply have to multiply 38 by 2. Are we getting that? Because 38 is actually half of the angle at the center. So you can say 38 times 2 or 38 plus 38 to get angle E. So say angle E, you say angle E will equal to 38 times 2, which will give us what? 76 degrees. Therefore, angle E is actually 76. If angle E is 76, then what are we going to do? So, look, this is the isosceles triangle, which simply means that the base angles are actually equal. Now we know the included angle are 76. How do we get to know these base angles? It's very simple. We simply have to subtract 78 from 180 and divide it by the two angles we're talking about. So it will be, if you want, you can say, look, the other simple way you can do it, you can say, okay, this is angle D, and we also have got angle D here because these base angles are equal. Then we simply say, for me to find the angle D, I will simply say this angle D plus this angle D plus this angle 76 will give us 180. Then what is a D plus D? That will be 2D plus 76 will give you 180. Okay? You say 2D equals to 180, take away the 76. Then say 2D equals to, what is the difference there? What is 180 minus 76?
Yes.
That will be 104, right? 104. Then remember, we want to find angle D. So say, okay, angle D will equal to, you divide by 2 here, also here by 2. So what is 104 divided by 2?
52.
That is 52. So therefore, angle D equals to 52. And of course, once you do that, you'll have computed all the, questions. And that's how you do and actually go about it. If you can observe very carefully, I told you a lot about this. So what you're able to see here is this. You can use the concept of angles in the same segment. You will say, okay, let me have this as my chord. This is my chord. Remember where any chord divides the circle into two segments. So if we are to check this one as our segment, okay, or rather as our chord, then we're going to have the minor segment and the major segment. Now, we are going to use the concept of angles in the same segment, take note. In this particular segment are actually said to be equal. So I'm talking about, we have got this particular angle. Are we seeing that? And this particular angle. We also have got this particular angle here and this particular angle. In simple terms, we can say, okay, if we don't want to use this particular segment, then we can also say, okay, why don't we use this particular arc? If you use this particular arc, this curve here, we see that, this angle that will be produced by this curve to this arc, okay, will equal to any angle that will be produced by the same arc. So we have 58 and y here. So y is actually equivalent to 58. As though that is not enough. For you to find the v, you now use this particular angle code. Observe this arc here. The angle that will be produced by this arc we have this angle here, and the same arc producing another angle 52. So these here are it's another. If that is not enough, you could use what we call the butterfly formation. Look at the upper wings. This is 58, it will equal to 1. The V will be equal to 52. So therefore we are saying angle Y is simply equals to 58. What of the angle V? Angle V will equal to what? 52. And you are done.